1.2 today, and it's on something called the unit circle, radian measure, arc length, and area. Okay, so we're going to cover basically 4 different areas. Some of this is going to be new material for a few of you. If you've had a trig class or a pre-calculus class, you may have seen this before, but all of this is going to be a good reminder. So we're going to start off with a couple starter questions. It says, what is the formula for the circumference of a circle? Circumference of a circle. Don't say anything out loud. Circumference of a circle. C equals, hey Melissa, what is it? Anybody know for sure? Okay, so it's going to be 2 pi r, and the area of a circle? Pi r squared. People get these confused all the time. Here's the way you can keep it straight. They each have a pi, they each have an r, and they each have a 2. It's just that they're in different places. Okay? If you have the circumference of a circle, that's just a plain old distance. If you have the area of a circle, that's going to be square units. That's why we have to take the radius that would be measured in inches or feet or miles or whatever it was, and we square that. So the square comes for area. Okay, so that's going to be on the area one. Okay, can anybody tell me what a conversion factor is? You've all had science, you've had biotech and all that sort of stuff. Conversion factor. Great. You don't know what it is, so I'll give you my definition. Okay, it is a funny looking 1. Every conversion factor is the number 1. It just doesn't look like it's a number 1. Okay? So if I'm going to take 250 meters and change that into kilometers, so I've got 250 meters. I don't want it to be in meters anymore. I want it to be in kilometers. So here's what I do. I know this. I know that 1,000 meters is exactly the same as 1 kilometer. This is going to serve as my conversion factor. So here's what I do. I multiply by something that doesn't look like a 1, but it is a 1. I want to get rid of the meters, so I'm going to put meters on the bottom. I want it to be kilometers, so I'm going to put kilometers on the top. Now, since these two things are equal to each other, if I put 1 kilometer on the top and I put 1,000 meters on the bottom, that doesn't look like a 1. If we brought a 5th grader in here and said, hey, is this the number 1? Does this fraction represent 1? They'd say, no way. Okay? But it is, because the units are different on the top and the bottom. So I can then cancel the meters. I'm going to cancel that 0. 25 and 100. Let's see, 25 goes in here once. 25 goes in here 4 times. So this is 1/4 of a kilometer, or we could write that as 0.25 kilometers. Either one of those would be fine. Okay, so that's a conversion factor. So if I want to change 54 inches into feet, here's what I've got. I've got 54 inches. I don't want it in inches anymore. I want it in feet. So the feet are going to stick around. I'll keep that on the top. If I want to cancel off inches, that's got to go on the bottom. Now, how do I make this a 1? Okay, 1 foot on the top is 12 inches. So I can cancel the inches, and then let's see what goes into 54 and 12 evenly. 6. Say 6. It is 6. Very good. Okay, so 6 goes in here 7 times, 9 times, 12 times. How many times? 9 times. So I have a 9 left here, and I've got a 2 left here, so this is 9 halves, or that's going to be 4.5 feet. 4.5 feet. 54 inches is 4.5 feet. And if you think about it, that's true, isn't it? Okay, let's take a look at the next one. I'm going to blow this up just a tad so we've got room here. I want to convert 2 miles into inches. 2 miles into inches. So I've got 2 miles. I want to change that into inches. So I need a conversion factor. I don't want the miles around anymore, so I'm going to put that on the bottom. Okay. Now, changing from miles directly into inches would be a pain in the butt. So let's think of a different unit that I could change it into. A mile is 5,280 feet. So if I put 5280 on the top, That's how many feet there are in a mile. I can cancel off the miles. Let me change colors so this looks a little bit better. Okay? So I can cancel off the miles. This is what I have right now. I've got something in feet, but I don't want that in feet. I want to cancel off the feet, and I want inches left. Notice how the unit that I want left stays on the top. The one I'm getting rid of is going to go on the bottom. So how many inches in a foot? 12 inches in 1 foot. So I can now cancel off the feet. So I have 2 times 5280 times 12 inches. So throw that in your calculator. That'll tell you how many inches there are in 2 miles. Okay? Somebody got that for us? 126,720. That's a lot of inches. Okay, 126,720. Okay, are there any questions? We doing okay? Am I going too fast or are we all right? Okay, all right, so let's take a look at what we're actually studying today. We're going to use conversion factors in just a second, but what we're going to talk about right now is something called the unit circle. So the unit circle has that name because it's a circle centered at the, help me out here, centered at the origin with a radius of 1 unit. Okay? We won't, it doesn't really matter right now whether it's feet, inches, yards, meters, kilometers, whatever it happens to be. Circle centered at the origin with a radius of 1 unit. That is the unit circle. Okay? Radius of 1 unit centered at the origin. Okay, and here's what we're going to do. We're going to mark the measure of the quadrantal angles on the unit circle in degrees. So we're going to start right here. So this is 0 degrees. And then remember, up here we go 90. We're going in a counterclockwise fashion. That's how we produce those positive angles. 180 degrees, 270 degrees. And if we go all the way around full circle, that's going to be 360 degrees. We talked about these the other day. Okay, degrees are not the only way to measure angles. We mentioned a couple others. The one that we're really interested in is this. We're interested in radians. Now, let's talk about what a radian is. Because I remember the first time I was introduced to radians and I thought that just seems really weird. Okay, and if somebody had said this to me, it would have made a lot more sense. Okay, what's the root word of the word radian? Radius. Okay, so the root word of the word radian is radius. And that's pretty much all a radian is. It's using the radius to measure distances around the outside of the circle. So there are a couple other ways that we can describe this. Okay, so a radian means radius. A radian is a real number. Okay, so it doesn't have any funky symbols on the side of it, like that little degree thing doesn't have that. Okay, it's just a real number. Okay, and radians represent a directed length. Okay, so it's literally a distance. It's a comparison to the radius of the circle. Now, here's the big advantage to using radians. Okay, I know if you've seen radians before, sometimes it's like, my gosh, why do we have to complicate things like that? Radians are really cool. The big advantage they have is they work really well in formulas. So we're going to come across lots of formulas. We're actually going to do some today. If you have to do it in degrees, they get to be a bit of a pain in the butt. But if you do it in radians, piece of cake. The answer just drops right out. Okay, now that's going to be advantageous for us now. It's going to be even more advantageous when you take calculus. Okay, they don't do calculus or anything beyond basic trigonometry in degrees. Everything else is in radians because it has such nice features. Okay? All right, so let's talk about why we'd use radians. So my first question is this. How many radii, and that's the plural of radius, okay, so how many radiuses does it take to go all the way around the circle? So if you started here and went all the way around, how many radiuses would it take? I hear a couple people saying the answer. I hear a couple people giving decimal answers that are pretty close. Okay, what's the length around the outside of a circle? 2 pi r. What does that r stand for? Radius. Okay? It's 2 pi radians, or it's 6.28 all the way around times whatever the radius is. Okay? So what we're going to do now is we're going to mark off the quadrantal angles on this circle in radians. So if we start right here, again, this is standard position. If we don't go anywhere, that would be 0 radians, okay? So that angle is completely closed right now. We haven't gone anywhere. But if we open it up just a little bit, bigger and bigger and bigger, and get up to right here, first quadrant, right here, this would be, well, let's think for just a second. We probably ought to break this down a little bit differently. All the way around the circle would be 2 pi. 2 pi radians. See that letter right there? That word right there that's attached to the R? So it's 2 pi radians all the way around. So unlike here, where it's really natural to go through and count, well, this would be 0, this would be 90, this would be 180, 270, and 360. We're going to figure out what these radian measures are by saying, okay, if we start right here, this is 0. If I go all the way around, that would be 2 pi radiuses, or 2 pi radians. Okay, see how we use those kind of interchangeably? So if it's 2 pi radians all the way around, what is it halfway? What if we go just over to here? Start here, go halfway. What would that be? If it's 2 pi all the way around, then halfway would be pi. Okay? And now we're ready to break it down even further. Now this division that we just made, top half of the circle and bottom half of the circle, is really important because that's going to serve to make things a little bit easier. So what if I just want this right here? I want half of the top half. If the top half is pi, this would be 1/2 pi, or pi halves we say. There's lots of symmetry here that you have to get used to. So if this is 0 and this is pi halves, and this is pi, another way to count here would be this. This is 1 pi half. This would be 2 pi halves. 2 pi halves. See how that's the same as pi? What would this be down here? 3 pi halves. If you wanted to say it this way, we don't do this ever, but you could say 1.5 pi. You could say that, I suppose. All right. So we've got all the quadrantal angles. They are 0, pi halves, pi, 3 pi halves, and 2 pi if we go all the way around. Everybody good with that? Okay. All right. So now we're going to come up with some other angles, the ones that we're more familiar with, 45, 30 degrees, 60 degrees, stuff like that. So we're going to convert 45 degrees into radians. Now I could come up here and I could say, you know what, here's 45 degrees right there. And I could draw that right here. And some of you may be able to figure this out in your head, and that's fine, or you may have seen this class before. But let's talk about how we actually make this conversion. So I want to take 45 degrees and I want to convert that into radians. So just like we did above, I'm going to use a conversion factor. Now, there are 2 conversion factors you could use. We could say that 360 degrees was the same as 2 pi radians. Remember, since you've got 2 things that are equal, we could use those as a conversion factor, just like we used 1 foot equals 12 inches. Or you could use this one. We could say 180 degrees is the same as pi radians. So don't write anything down yet, just watch. Let's say I'm going to convert this one, and I used, let's see, I want to get rid of the degrees and turn it into radians. So I'm going to put the degrees on the bottom, 360. Again, don't write anything down. And this would be 2 pi radians. Now I'm going to write the word radian for a little bit, and then we'll just drop that off. Okay? So I could cancel the degrees with the degrees. And then let's see, 45 goes into 360. Let's see, 45 goes in there once. 45 goes in here 8 times. And then I can cancel the 2 with the 8. That would be a 4. So if you take a good look here, the only thing left on the top is a pi. The only thing left on the bottom is a 4. So it's pi 4th radians. Now, that works just fine, but if you take a look here, I could have canceled the 2 with the 360 anyway. What would happen if I canceled the 2 with the 360? You'd have pi over 180. So let's just use this one from the get-go. So let's not use 2 pi over 360. Let's use pi over 180. And then let's just go from there. So those cancel. 45 goes in there once. 45 goes in there 4 times. So it's pi 4th radians. Good with that? Okay. Let's do 30 degrees into radians. 30 degrees. I want to get rid of degrees, so I'm going to put 180 degrees on the bottom. I'm going to put pi on the top. The degrees cancel. Notice I have no more funky units or anything like that. This is just a real number. So, cancel off the zeros. 3 goes in here 6 times, so the answer to this is pi 6. Pi 6th radians. Okay, you try the next one. This is the opposite. This says go from radian measure to degrees. I want it in degrees, so that tells me where I need to put the degrees in my conversion factor. I need to put it on the top, so 180 degrees. This would be pi radians here. Notice that something nice happens. The pi's cancel. 4 goes in here once, 4 goes in here 45 times. So I have 5 times 45, and 5 times 45 is 225. 225 degrees. Any questions? Okay. That seems like a bit of a pain in the butt. So let's look at it visually and see if we can figure it out that way. This one right here? Okay. So what we did is we took 5 pi fourths, just wrote it down here. And then since I wanted to change this into degrees, I've got to have the degrees on the top and the radians on the bottom. So see how that's 180 degrees is the same as pi radians. So once I set that up, I just do the arithmetic. So I'm going to cancel pi here with pi here. I'm going to cancel 4 goes in here once. 4 goes into 180 45 times. So I have 4 times, see, so 40 times 5, that's 200. 5 times 5 is 25, so 225. Good there? Any other questions? Okay. For most people, now you do have to know how to do a conversion like this. For most people, the conversion is a little bit easier if we think of it this way. Okay, because you're going to have to memorize these anyway. Let's start here at 0. This is pi. Now we're going to work on the top half of the circle. This is half of the top half, so this would be pi halves, right? What would that be right there? Pi fourths. It's a fourth of the top half of the circle, so this is going to be pi fourths. What would this be right here? If this is a pi fourths, and that's a pi fourths, and that's a pi fourths, how many pi fourths do we have? 3. So we say that 3 pi fourths. Okay? So you can kind of see there's a fourth, there's a fourth, there's a fourth. And this would be, if we wanted to write it this way, how many fourths would I have here? 1, 2, 3, 4. 4 fourths is the same as 1 pi. Okay, how are we doing now? Going too fast or are we doing all right? Okay? All right, so that takes care of pi fourths. Now, this is the equivalent of 45 degrees. This is the equivalent of 90 degrees, and this is the equivalent of, let's think for just a second, 135 degrees. Everybody okay there? Okay, now, 30 degrees was pi 6. So let me draw that in right here. 30 degrees would be about right here. That is pi 6. So let me draw that piece. If I did another one, okay, so this slice right here is pi 6. If I did 2 slices, that would be 2 pi 6. Now, would we really write 2 pi 6? Nope. So this is going to be pi thirds. Okay, so that's how we say that, pi thirds. So here's what we've got. 0, pi 6, pi fourths, pi thirds, pi halves. Now, if I did another one here and another one here. So let's count. 1 pi 6, 2 pi 6, or that would be 1/3. 3 pi 6, 3 is half, so that's pi halves. What would this one right here be? 4 pi 6. Am I going to write 4 pi 6? Nope, I'm going to write 2 pi thirds. And this one right here, how many pi 6 would that be? 5 pi 6. Okay, any questions there? Okay, is everybody watching? Okay, watch. So I drew these slices. Those are fourths. Then I drew these slices. Those are sixths. Did I get that right? All 6 of them? Okay. What if I did this? Is this okay? Pi thirds. Wouldn't that be 2 pi thirds? And what would this be over here? 3 pi thirds. So I'm going to write this again. Isn't 3 pi thirds just the same as 1 pi? Same as pi? Everybody good with that? Any questions? Yeah.
Where did the 5 pi over 6?
The 5 pi 6? Okay, that's this little slice right here. Okay. So if this is 1/6 of pi, this slice would be, so let me mark them off. There's 1/6, 2/6, 3/6, 4/6, 5/6.
Okay.
And the next one would be 6/6, so that would be 1 pi again. Okay, good question. Anything else? We're good there? Okay, so I'm going to blow this up just a tad, and then we're going to fill in the bottom half of the circle. But we're also going to look at this, and we're going to remind ourselves, you know what? These have degree equivalents. This is 0. This is 30. This is 45. This is 60. 90. Don't say anything out loud. I'll give you just a second to think about it. This is going to be 120. Another 45 degrees here, so that's going to be 135 degrees. Okay, watch. 5 pi 6. Don't write this down, just watch. 5 pi 6. I want to know what that is in degrees. Now, a lot of you probably already know. You can kind of spot the pattern here. But if I wanted to change this into degrees, I'd do 180 degrees over pi. Cancel, oops, cancel here. 6 goes in here 30 times. 5 times 30 is 150. So this is 150. Now, does that look like about 150 degrees from standard position? Yep. And if I add another little 30-degree slice to 150, this would be 180. Any questions? Okay. I'm going to do the bottom half, and I'm going to go a little bit faster, if that's okay, since we've already got the top figured out. Everybody good there? Okay. All right. So let's see. This would be, we already got this one, 3 pi halves. This is 2 pi all the way around. Okay, let's look at the symmetry here. Let's do these guys. Let's do the ones with 6. So pi 6, 2 pi 6, 3 pi 6, 4 pi 6, 5 pi 6. 6 pi 6, what's this guy right here? 7 pi 6. Let's see, 8 pi 6. 8 pi 6 would be 8 pi 6. 4 over 3. 4 pi thirds is how we say it. Another one. Pi thirds, 2 pi thirds, 3 pi thirds, 4 pi thirds. What would this one be? 5 pi thirds. And this one? It's in sixth. 7, 8, 9, 10. 10 pi 6 is 5 pi thirds. 11. If we add another 6, that would be 12 pi 6. 12 pi 6 is 2 pi all the way around. Okay? Let's fill in these little guys right here, the multiples of 45 or multiples of pi fourths. So this would be pi fourths, 2 pi fourths, 3 pi fourths, 4 pi fourths. What's this guy right here? 5 pi fourths, 6 pi fourths. So what's this one over here? 7 pi fourths. And let's see, let's write these down then. Another 30 degrees would be 210, 240, 270. That should make us feel better that we fit that nice pattern there. This is 300, this is 330, and if you go all the way around, 360 degrees. I've left out 2 measurements down here. This one is, well, if that's another 45 degrees, 180 plus 45 is 225 degrees. And this one over here, this is 40 degrees short of 45 degrees short of 360 degrees. So this is, somebody tell me? 315. Thank you very much. Okay? Any questions there? Okay, so if you'll take a look at this part right here, you really need to know these inside out and backwards. Not today, but when you come next week, these need to be at the point where they're becoming second nature. Very easy to recall. So for example, if somebody says 11 pi 6, you need to quickly be able to say, well, let's see, 11 pi 6. That's a sixth short of 2 pi, so that's going to be in the 4th quadrant, closer to the, what axis? Closer to the x-axis than the y-axis, and let's see, we'd have to convert that. 11 pi 6 is the same as 330 degrees. That stuff in right here that we just filled in, what quadrant it's in, what axis it's closer to, and we generally refer things to the x-axis, okay? And what the degree equivalent is, that needs to be second nature. Or if somebody says, we've got 225 degrees, you need to know that that is in quadrant 3, that it's right in the middle of quadrant 3, right there. Okay, that's the one we're talking about, right here. And it's the same as 5 pi fourths. Okay? That needs to be second nature. So, to help you with that, I don't want you to do this right now, but I've got this. This is a blank unit circle. Nice big one. It's 3-hole punched. You can do that. Fill that in. I mean, I know it's tough to scribble on the bottom of that little page. But you can fill that in. You need to get that memorized. Some of you might already have it memorized. Okay, any questions? Did I make a mistake? No. Good. Okay, so flip it over to the next page. So if you look in the textbook describes radians as a directed length. And here's what they mean by direction. Just like with regular angle measurements in degrees, if we're going counterclockwise, that's positive, and if we're going clockwise, that's going to be negative. So let's mark some of the common angles. Let's mark them going the negative direction. So this would be 0. What if we were right here in the middle of quadrant 4, but we went in the negative direction? What would this be? Negative 45 degrees, or in radians, negative pi fourths. Right here, negative side of the y-axis, this would be negative pi halves. This would be negative pi. I'm going to stretch you just a little bit. What would this one right here be? That common angle that's closer to the x-axis than the y-axis in quadrant 3? Like negative 150 degrees, and what is it? Negative 5 pi 6. Okay? So if we mark the other ones here, it's going to look like this. This is going to be negative pi sixths, negative pi thirds. This would be negative 2 pi thirds. This one here is going to be negative 3 pi fourths, and so forth. We could go all the way around the circle. What is this one right here? Negative 3 pi halves. Okay? And what if I did this one right here, closer to the y-axis? Oh, now we're really stretching here. What is that one? You could look on the other page to figure it out. It's going to be negative because we run around in the opposite direction. 5 pi thirds. There we go. Okay? So you could mark all of those off. Now, we're going to use this to remind ourselves about coterminal angles. This says find two positive angles that are coterminal with pi fourths. Coterminal with pi fourths. So, pi fourths is right here. Another one that's positive would be go around this another full circle. Now, we use this formula right here. We said if it's coterminal, you take the original measurement of 45, or in our case, it was, whoops, get this right, pi fourths. How would we change this? It's right now 360K. How would we change it so that it's in radians? What's the same as 360? 2 pi. So we're going to do 2 pi k. Well, once around the circle, I'd replace that with a 1. So if I add 2 pi to this, let's see, 2 pi in fourths. So this is where people get frustrated with radians. They've got to work with fractions a lot. This is the same as pi fourths plus 8 pi fourths. So that's going to be 9 pi fourths. There's one answer. Okay? If I did 2 of those, that's going to be 4 pi. So this is going to be pi fourths plus 4 pi. Let's see, 4 pi in fourths. How many fourths would that be? 16 pi fourths. So this is going to be 17 pi fourths. There are two angles that are coterminal with pi fourths that are both positive. So we could go around the circle twice, 3 times, whatever. This one says come up with 2 that are positive and coterminal. Let's find 2 angles that are coterminal with 2 pi thirds that are negative. So instead of going around in the positive direction, what are we going to do? Go in the negative direction. So we're going to subtract 2 pi. And then for the other one, what would twice around the circle in the negative direction be? 4 pi. And then we just have to do the arithmetic. And what you'll find is sometimes the further you go in math, the ideas aren't that bad, but you've got to remember a whole bunch of stuff, algebra, arithmetic, things like that, in order to get them straight. This is going to be the same as 6 pi thirds. 6 pi thirds. So we've got 2 pi thirds minus 6 pi thirds. That's going to be negative 4 pi thirds. There's our answer on that one. In thirds, what is 4? Yeah, this is 2 pi thirds minus 12 pi thirds. So this is going to be negative 10 pi thirds. Okay? All right. Any questions? Doing all right? Okay. Okay, let's take a look at the next one. Okay, every angle measurement in radians that we've worked with so far has the symbol pi in it, because we're measuring it as a fraction of the full circumference of the circle. Okay, not every radian measure has that. So if we were to look at this and start right here at 0, if we went around full circle and did it as a decimal, that would be 6.28. This over here would be pi. What would that be as a decimal? 3.14. And if we did half of that, it would be 1.57. And if we did this guy right here, 4.785, I believe. No, let's see, 4.7. Let's see, what is 3 pi halves? So if we did 3.14, let's grab that. 4.71, so I did have that right. So 4.71, okay? So if somebody said draw an angle of 4, I mean, the first question would be, well, 4 what? 4 degrees or 4 radians? How can you tell which it is? It doesn't have the degree symbol on it. If it doesn't have the degree symbol on it, it's got to be radians. So 4 radians would go in the positive direction. There's 1.57. 2 would be somewhere around here. Here's 3. 4's got to be somewhere in between these two, probably a little bit closer to this one. Okay, so there would be 4 radians. What about negative 4? This would be negative 1.57. This would be negative 3.14. This would be negative 4.7. So negative 4 radians would be somewhere about right there. It'd be tough to graph those perfectly. Okay? And then let's do 10. So if we were going to do 10 radians, first of all, we're going to go in the positive direction. So all the way around is 6.28. If I did another half circle, let's see, that would be 6 plus 3, that would be 9.42 here? Well, 9.42, we're pretty close, so 10 would probably be somewhere around right there, in that ballpark. Okay? Any questions? Okay. All right. Just enough time to finish up then. So the last couple problems deal with formulas, and it looks like I have, oh, did I make a mistake? They're both example 4. Well, we'll see what we can get through here. This one says, find the arc length cut by a 60-degree central angle on a circle with a radius of 3 feet. So here's our 60-degree central angle. If we want the arc length, all we want is how long would a string have to be to stretch from here to here? Well, the formula, if we do this in degrees, is kind of ugly, because you have to do this. The arc length, and we use S for arc length, you have to put the measure of the central angle over 360, and then we times that by 2 times pi times whatever the radius is, and the radius is 3 feet. That's how you do that problem right there. So basically what we're doing on this problem is we're figuring out what fraction of the circle we have. So this would be 1/6 of 2 pi times 3. Well, I can cancel the 2 and the 3 with the 6, so the answer is pi feet. That's the formula. In fact, I guarantee every one of you saw that in your geometry class. Probably don't remember it, but you probably saw it. Here's the formula in radians. Looks a lot shorter. All we need to do is make sure that that is in radian measure, and we're in good shape. So, can you remember what 60 degrees is in radians? Look at your chart if you have to. It's pi thirds. So here's the formula. Take the angle measure, multiply it by the radius. Cancel the 3's, what's the answer? Pi feet. So do you see what I mean when I said radians have this nice advantage that they work really well in formulas? There's the formula right there. Very short, plug it in, spits out the answer. None of this figuring out what fraction of the circle we're dealing with. And the reason for that is radians kind of already tell you what fraction of the circle it is. If we're at pi halves, that's 1/4 of the entire circle, okay? Because it's 2 pi all the way around. So the other formula that we're going to need is this guy right here. Whoops, this one right here. So we've already got arc length. Arc length is right here. This is the area of a sector. Let's go ahead and fill this in. Here's the formula if you use radians. It's alpha over 2. So take the angle measure in radians, divide it by 2, multiply by r squared. So let's do this problem right here. It's alpha over 2 times r squared. So what's our alpha? What's our angle measure in radians? Pi thirds. So pi thirds divided by 2 times, and what is our radius? 3 feet. So here's what we've got. Everybody watch, please. You're taking a fraction and dividing by a number. It's much better to think of everything as a fraction. So instead of dividing by 2, multiply by 1/2. So this is going to be pi 6 times 9 square feet. 3 feet squared is 9 square feet. Cancel. 3 here, 2 here. So this is 3 pi halves square feet. Any questions? Yeah.
Why did you times by 1/2 again?
Because, slide this up. Instead of dividing by 2 over 1, we never divide by a fraction, we flip it over and multiply. Dividing by 2 is the same as multiplying by 1/2. Everybody good there? Okay. Now, let me just, so this formula works. Let me just do one more thing to convince you. What would this formula look like if our angle was the entire circle? So if alpha wasn't 60 degrees or pi thirds, or any other fraction of the circle, what if it was the entire circle? What would happen if we plugged this in right here? We'd have 2 pi over 2 times r squared. Well, what would that be? That would be pi r squared. That would be the whole circle. Think about that for a minute. This formula works as long as you put in the radian measure. Okay? All right. So you've got a problem on your assignment. It's problem number 91. It says find the area of a sector with a central angle of 30 degrees and a radius of 6. Okay, 6, whatever, just call them units. Okay, if we're going to use these formulas up above, what do we need to do with this? Switch it into radians. So let's think for a second. We already talked about this. We converted this already. What is 30 degrees in radians? Okay, so it's going to be pi 6 is alpha, and the radius is 6. So our area would be pi over 6 divided by 2 times 6 squared. Dividing by 2 is the same as, so this is going to be pi 6 times 1/2 times 36. If you want, 36 pi over 12, so the answer is 3 pi. Okay, and technically we'd have units squared on that. Okay, so I'm 1 or 2 minutes over. I'll put this lecture on the website if you need to watch this again. Please complete this blank unit circle here. You need to have those memorized. Okay, those need to be just absolutely second nature. And please make sure that you read section 1.3 before class next time. So next time we're going to correct 1.1. You should be done with maybe some minimal questions on 1.2, and you should have definitely read 1.3. Monday's going to be a little interesting. If anybody struggles with something in chapter 1, it's usually the stuff in 1.3, and it usually shows up on the final, even though the problems are a little bit obscure. Have a